Chapter 4. What is humidity? Humidity is an important aspect of the atmosphere because it affects both weather and climate. In this chapter, you will learn about the different types of humidity and understand how temperature affects water vapor in the air. What is humidity? Have you ever heard the phrase, "It's not the heat, it's the humidity"? People say this because humidity, which is the amount of water vapor in the air, can make hot temperatures even more unbearable than they already are. Humidity is actually a broad term, and we can describe different types of humidity in different ways. Humidity is an important thing to understand because it affects weather and climate as well as global climate change. Humidity also affects indoor environments, so understanding it can help you determine the best place to store your books, clothing, and other important items in your house. Relative humidity. You've probably heard about relative humidity in weather reports. It is the amount of water vapor in the air relative to what the air can hold. Think about it this way. If you have a cup that is half full of water, the cup contains 50% of what it can hold. Air works in a similar way. It's important to know that warm air can hold more water than cold air. You can think of different temperature air like different size cups. Smaller cups hold less water than larger cups. In this case, cold air is a smaller cup and warm air is a larger cup. So when the air is colder, the same amount of water vapor will produce a relatively higher humidity than the same amount of water vapor in warmer air. This is because we have to consider the amount of water vapor relative to what the air can hold. How full the cup is relates to how much the cup can hold overall. When we apply this to air, we can see that for the same amount of water vapor, the relative humidity will be higher for cold air than for warm air because the cold air is fuller from the same amount of water. When air becomes saturated, this means that it contains the maximum amount of water vapor possible. Just like relative humidity differs with different air temperatures, saturation is also temperature dependent. Saturation occurs when the cups are completely full of water. Just like the smaller cup needs less water to become full, cold air becomes saturated from less water than it takes to saturate warm air. And just like if you kept filling the cups even though they were already full, the water would have to go somewhere, so it would spill out over the cup and fill the surrounding area. Humidity affects weather. Humidity plays an important role in both weather and climate on Earth. Water vapor is a key greenhouse gas which helps block harmful UV rays from the sun as well as traps heat on Earth that makes life possible. Water vapor in the air comes from water on land and in the oceans. It evaporates into the air, which is an important part of the water cycle on Earth. Without this step, we would have no rain or snow, which helps cycle water back to the ground and feed our rivers, lakes, and streams that we depend on for drinking water. However, because it is such a powerful greenhouse gas, water vapor can be quite the double-edged sword. Like a nice blanket on a cold day, we depend on water vapor in the atmosphere to give us just the right amount of protection and warmth. This now brings us back to the end of Chapter 4. Understanding the intertwined nature of temperature and humidity is a very crucial aspect